Alright, in our previous video, we differentiated this. And we got, let me write it up here. Let me erase these things that I have and write it up here. What we got was that dy by dx is equal to 35x to the fourth minus 3x squared over 2y. Now, suppose we try a little thing here. Let me say, suppose you should transpose this function for y and differentiate it. Would it work? Would you get the same thing? Let's see. Y squared, let me do it in white. Y squared will be 7x to the 5 minus x cubed, and then y would be the square root of 7x to the 5 minus x cubed, right? Which is the same thing as saying y is equal to 7x to the 5 minus x cubed raised to the power of a half. Now, if you're going to differentiate this, you have to use a chain rule. You say let y is equal to, all right, let u be equal to, so u is equal to 7x to the 5 minus x cubed. All right. So y is equal to u raised to the power of a half. We're just trying a thing here. Now du by dx. So du by dx would be 5 sevenths 35x to the fourth minus 3x to the square, 3x squared. You see that? Multiply by 5, 5 7 35, x to the 5 minus 1 give you 4, minus 3 times x will be 3x, 3 minus 1, 2. Alright? So that's du by dx. So this 7x to the 5 minus x cubed, when you differentiate it, you get 35x to the fourth minus 3x squared. What about the y equal u to the half? dy by du. dy by du would be equal to half u to the half minus 1, which is negative a half. Alright. So it's half u to the negative half. Now, therefore, let me just partition the board here. What you would have is that dy by dx is dy by du, which is half u to the negative half. But remember, u is 7x to the 5 minus x cubed. So we can just write that from now. Half u to the negative half. But it is half 7x to the 5 minus x cubed. Just erase the u and write that, since we don't have a lot of space, to the negative half times dy by du. That's dy by du is that, times du by dx, which will be 35x to the fourth minus 3x squared. Now, what does this amount to? This is 35x to the fourth minus 3x squared all over squared. Alright. Now all over this, now all of this should multiply by a half, so half times this, 7x to the 5 minus x cubed to the half. Because remember, when you raise to the negative power, it's like 1 over to the positive power, is to the half. But when you raise to the half, you're really finding the square root. So you're really finding the square root. All right, good. Now this is 35x to the fourth minus 3x squared over 2 times, but notice the square root of 7x to the 5 minus 3 minus x cubed is the same as y. We saw it here. Y equals square root of 7x to the 5 minus x cubed. And this is square root of 7x to the 5 minus x cubed. So we might as well just write y. Now what do we get? It's the same thing. 35x to the fourth minus 3x squared up top over 2y. 35x to the fourth minus 3x squared up top over 2y down the bottom here. So it's over 2y. So you actually get the same thing. It's actually the same thing here. It's just that we were able to transpose this function to make y the subject. And it was relatively easy to transpose. And then we compared it with what we got by implicit differentiation in the previous video. And we get the same thing. Alright, so in this case, we see that transposing for y to make the function explicit and then differentiating, or when you don't transpose for y, doing the differentiation explicitly, you will get the same thing as when you differentiate using implicit differentiation.